Welcome back everyone, this is Preetham with another SAT math walkthrough, but unlike our regular videos where I just do one to two or three problems, we are going to do a whole set, and it's going to be fun, so brace yourselves. Anyways, for those of you who don't know me, I am a credible source for this section of the test since I am a perfect scorer. Right there, 800 math. Excuse my reading, but that's irrelevant in this case. Let's get started. So, as you can see, these are the formulas. You don't need to read them, because I'm sure if you're in high school, you'll be knowing all of them on top of your head. Trust me, you don't use half of those. I don't know why they print it in there. No offense, College Board. So anyways, in the following equation, A is a constant for which of the following will the equation have no solutions. So, this is a linear system. Ax equals 5 is a linear system, and there are three solution cases for a linear system. One of them would be when it's one unique solution, when you have variable x or whatever variable equal to a constant, and that is a unique solution. I'm just going to write E right there. And another case is when you have infinitely many solutions, that is when you have a constant c equal to another constant c, that is infinitely many solutions, which means that they're basically the same line. And now here is where it gets sketchy. This is a no solution case where you got a 0 equals constant. And you know that is just not possible in any case, so that's no solution case. So let's just try to solve this problem. To solve this, we would need a 0 on one side of the equation. There's no way I'm getting it on the 5 side. So anyways, let me just grab my green pen again. So A is a constant. So it is just some number. And as I know, the zero product property, whatever I multiply by 0, just gives me a 0. So my answer to this question would just be a 0. That's straightforward reasoning. We shouldn't have even taken this long. Anyways, moving on to number 2, this looks like an even more interesting problem with a variable on either side. This is a linear equation, so that is 9x plus 15. Because I just foiled it. I just distributed the 3. Not exactly foiled, but distributed. So now that's 2x minus 8. Now, I'm just going to stick to my guns, get the variables on one side and get the constants on the other. That's 9x minus 2x equals negative 8 minus 15. So now, simplifying this, that would give me 7x equals negative 23. And x would just be dividing by 7 on both sides, so that's negative 23 over 7, and that is my answer choice A right there. So there we are. Moving on to question number 3. Oh, these ones take some time to do. Anyways, this is my personal strategy. I always start, like, whenever I have a function and then a variable and the answer, I just do the plug and chug strategy. Is what Princeton Review calls it, but I call it the plug strategy. Sorry, Princeton Review. Anyways, so this is going to be, I'm going to start my process of elimination from equation A. So that is 2x minus 3. I'm not going to pick the first point because I know the College Board is sketchy enough to just lure you into the wrong answer. So I'm going to pick my third variable, that is when x equals 6, and this h of x would be 13. So now plugging that in, substituting that in, would give me 12 minus 3, which is 9, and that is not 13, so I'm getting rid of a. It goes right out the window. I'm not talking to it anymore. And now, I'm just going to pick the first variable again for fun, because who knows, it might get another choice out the window. So yes, I'm going to pick the D choice right now. 4 times 2 minus 9 gives me negative 1, and that is not 1, so D goes right out the window too. And now I'm going to stick to my third variable, that is when x is 6. So now I'm going to substitute that into my third equation. So I'm just going to, something's got to give right now, because I have 50-50 chance of getting this right. So now 4 times 6, which is 24, minus 7 is 17, and 17 is not 13. C goes right out the window too, and there we are, our answer choice is B. So whenever you are substituting, I would just prefer not to start with the first variable, because I'm sure the College Board is smart enough. Come on, they've been doing this for 120 years. Just as something that many experienced test takers say as well. So since they've been doing this for nearly a century now, they would know what students generally think. So it's advisable not to start plugging in from the first equation. Just start from B or C. Anyways, question number 4. Someone's car, Terrence's car, contains 8 gallons of fuel, and he plans to drive the car M miles using the fuel currently on the car. So M miles of fuel, M miles, that is going to be driven. And now he's got 8 gallons of fuel, and we have 20 miles per gallon. That's the mileage. So what are the maximum number of miles he can drive? Gives me 20 times 8, which is 160. Oh, excuse that 0 right there. That's got to be a 0, but it looks like a 6. But anyways, I'm going to just erase that right away and fix that. That is a 0. Yep, right there. So now 160's got to be on one side of the equation, so I know 20 times 8 is 160, so I get rid of choices B and D. And now this might not seem the most obvious thing to do, but you just got to grasp this right now, because like you can drive at max 160, which means M should be less than or equal to 160. Because there's no way on earth you're going more than 160 miles, which is 20 miles per gallon at 8 gallons. So our answer choice is A. There we are. Anyways, oh, there are the angles. I love these. These are my favorite and probably the most easiest questions on the test. So, in the figure above, line T intersects line L and K, which of the following statements, if true, would imply that lines L and K are parallel. So, as you know, the parallel lines and then a line intersecting it is a transversal. So I'm just going to call T the transversal. Can't spell that out, but I'll try my best. Oh, forget it. Just know it's a transversal, because that is not the most relevant thing right now. Just know that's the transversal. Anyways, wow. My undo function took me one step too far. Interesting. Anyways. So now angle W equaling angle Y tells me nothing about about lines K and lines L, because they're vertically opposite angles, so that just tells me that they both are equal. That tells me nothing about the parallel functions or parallel lines of these, so I'm just going to get rid of choice A right away. And now angle W equals Z, that sounds like a viable choice, so I'm just going to keep that. Now X and Y, X equals Z. There is no way that's true, because X has got to be equal to this angle theta right there. So just because X has got to be equal, oh, excuse that, theta. So let that angle be theta. Since X has got to be equal to theta, it's got to be equal to 180 minus Z. So X minus Z goes out the window too. And now the last choice, X plus Y equals 180. That just tells me that there is a flat line. That just tells me T is a line and it's been cut by L. It tells me nothing about L and K, so I get rid of that too. And there's my final answer. So I'm just going to tell you why this is true, because W is equal to this angle A right there. And A and Z are vertically opposite angles, so that's the reason they are both equal. And if they're both equal, this implies that T is the transversal. And now a transversal cutting two parallel lines would give me a situation like that. Anyways, moving on to question 6. Blood volume in a human can be determined by using the equation where BP is plasma volume and the hammock. Can't say these. Anyways, which of the following correctly expresses the H word? I'm just going to call it the H word in terms of the blood volume and the blood plasma volume. So anyways, what this is telling me is to just solve for H, And now I have my equation, VB equals VP over 1 minus h. To solve for h, I'll need to have it on the numerator because like it's just going to get awkward when I try to solve it from the denominator. So I'm just going to swap places of VB and 1 minus h because I'm just going to cross multiply them. 1 minus h equals VP over VB. So something tells me right off the bat that no, equation D is wrong because VP and VB are supposed to be numerators and denominators, not adding and subtracting partners. So anyways, to solve for h, I am just going to transpose h to the other side. That is 1 equals VP over VB plus h. Okay, choice C looks identical to this, but it's not quite. So I'm just going to get rid of choice C because I know that if I am to solve for h, VP over VB is to have a negative sign. So I just go look for it and A is my answer. And like I just finished it without, I just narrowed it down through elimination, but guess what? I'm just going to just go ahead and prove it. So h equals 1 minus VP over VB. That would be the final step in the algorithm. So this is because VP over VB plus h add up to 1, so h has got to be the difference between 1 and VP over VB, and that's clearly what choice A is. Moving on. Oh, this is another interesting problem. I know many of you might be looking at variables in both the numerator and denominator and say, oh crap, this requires cross multiplication. But yes, it does, but it eventually will, and you don't need to be solving quadratics at this point. So to make this a little easier to solve, I'm just going to go ahead and distribute the 2. That's 2x plus 2 over x plus 5. So that would be my first term. And then I'm just going to go ahead and transpose the second term on the right hand side to the left hand side. So that's, I'm just going to be adding 1 over x plus 5 right there equal to 1. Since I have the same denominator, I can go ahead and combine the numerators. That's 2x plus 3 over x plus 5 would be equal to 1. And now cross multiplication, our close friend, comes into play right now. 2x plus 3 equals x plus 5. And now, of course, linear equations rule number 1. Variables on one side, constants on the other. So that's 2x minus x equals 5 minus 3. And x would just be equal to 2. And that is choice B right there.